Hello everyone, my name is Saksham Sojitra. My ID is 24DCS126. Now my topic about power optimization techniques for digital circuit. Power optimization in digital circuit refers to the process of minimizing the power consumption of circuit while maintaining its functionality and performance. The goal is equip you with tools for energy efficiency. Voltage scaling. There are two types of voltage scaling, quadratic impacts and trade-offs. First one, quadratic impacts. Power consumption is proportional to the square of the voltage. Reducing voltage scientifically cuts power. Trade-offs. Lowering voltage increase circuit delay. Careful optimization is need to maintain performance. Clock gating. Clock gating is a technique used in digital design to reduce power consumption by selective disabling the clock signal to certain parts of a circuit when they are not in use. Power gating. Power gating complete shutdown refer to a technique in integrated circuit design where a specific block or section of a circuit is completely disconnected from the power supply effectively shutting is off entirely when not in use. Backup latency. Introduce latency when reacting the block, not switchable for frequently switching block. Multi-variety design. A different threshold. Use transistor with different threshold voltage like low VT for a speed and high VT for a low leakage. Strategic placement. High VT transistor in non-critical path reduce leakage without impacting performance. Multi-supply voltage. First, multiple voltage applies a different supply voltage to different blocks. High voltage for performance and low voltage for power supply. Second one, a level shifter. A level shifter is an electronic device that changes to the voltage of signal between different circuit for a microcontroller. Dynamic voltage and frequency scaling. Adaptive controller dynamically adjusts voltage and frequency based on workload demand. Second, power saving. Power saving refers to the practice of reducing energy consumption in order to save electricity and ultimately reduce cost of environmental impacts. Clock frequency reduction. Clock frequency reduction refer to the process of decreasing the speed at which computer central processing unit operators. First, reduce frequency. Lowering the clock frequency reduce dynamic power, direct linear relationship, performance impact. Reduce processing speed only switchable when high performance is not required. Restructuring. Logic restructuring means involves a reorganization the logical flow of a system or processor to improve efficiency, clarity, and effectiveness. First, minimize switching, optimize logic gates, reduce unnecessary transition and glitch. Second, gate sizing, adjust transistor size and balance performance and power consumption. Now, operand isolation. Operand isolation is a technique used in computer programming to separate and isolate individual operands within an expression or equation. Operand isolation can help improve code readability, maintainability, and debugging. Low swing signaling. Low swing signaling is a term used in electronics to describe signaling method where the voltage swing between high and low state in minimize. First, reduce power consumption. Lower voltage swing means less power used per transistor. Second, faster switching speeds. Smaller voltage change enable quick signal transitions. Memory optimization. Memory optimization is the process of improving the efficiency of computers' memory use. First, minimize access frequency. Reduce how often memory is accessed to save power. Second, optimize data placement. Place frequently used data close to the processor. Third, use low power memory. Employ memory technologies designed for efficiency. Asynchronous design techniques. Asynchronous design techniques means refer to the approach of designing digital circuit or system without a global clock signal. First, eliminate clock network. Reduce the power need to slice a clock. Second, demand driven activation. Activate circuits only when data is available. Third, lower power consumption. Decrease overall power used during the circuit. Approximate computing. First, error tolerance. Error tolerance refers to the ability of a system, process, or model to continue functioning correctly even when error of the fault occurs. Second, reduce complexity. Reduce complexity refers to the process of simplify system model or problem to make it easier to understand, analyze or solve. Third, power saving. Power saving refers to practice of process of reducing error, reducing energy consumption in device, system or minimizing electricity use and prolong battery life. Activity driven power optimization. Activity driven power optimization refer to technique used to reduce the power consumption of device or system by adjusting its power use based on the activity or workload being processed. First, identify active components. Find most frequently used circuit. Second, optimize critical paths. Reduce switching activity there. Third, implement power gating. Isolate unused circuit. Supply gating and dynamic power rails. Supply gating cuts off power to idle blocks. Dynamic voltage scaling adjusts voltage based on workload. First, isolate idle blocks. Completely shut down unused circuit section. Second, dynamic voltage scaling. Adjust voltage to the performance need. Third, maximum power efficiency. Optimize consumption of the workload. Adaptive body biasing. ABB adjusts transistor threshold voltage. These components for process variation and temperature changes improve power and performance. First, threshold control. Fine-tune transistor performance. Second, thermal stability. Maintain stable operation. Third, process variation. Components for manufacturing issues. Power-aware placement and routing. Optimize physical layout to minimize power. Reduce wire length and congestion to lower capacitance. Place active blocks clock together. First, minimize wire length. Reduce routing distance. Second, reduce congestion. Optimize signal path. Third, place active blocks together. Reduce power in long circuit. Low power design tools and methodologies. Utilize specialized tools for power analysis and optimization. Adopt methodology like power budgeting and verification ensure efficient design flow like 50% reduction power saving with new tools and 2x faster simulation speeds. Thank you.